This video is about significant digits. Remember that significant in this instance means measured, not important. So there's a difference between an important number and a measured number. Also, significant digits can also be called significant figures, so don't let that throw you off. If at any point during the video you would like to write something down, feel free to pause the video to write, because I'm going to work through this fairly quickly so that you can see, use it as a recap on what we've already been through. That's the definition of significant digits. All the certain places that you're certain of plus one estimated one. So when someone takes a measurement, they take it with all the certain places plus one estimated one. So when you do a calculation using those measurements, your calculation can only represent all the certain places plus one estimated one. So the set of rules for how to figure out which numbers to count and which numbers to not count as significant. In other words, did they measure it or did they just put it there to hold a place, are the following. First of all, if the number that you're looking at is not a zero, it always counts as a measured place. So in 1.22, there are 3 significant figures or significant digits. 9,456, none of those are zero, so all 4 count. The number 8 is not a zero, so it counts. And 8.2, no zeros, so they all count. So as long as it's not a zero, it automatically counts as measured. The second rule then, well actually all of the rules hereafter refer to the zeros. The second rule here is that if the zeros are in between other significant digits, they always count. So if they're sandwiched or trapped in between, they count. So for example, in the number 2005, those 2 zeros are trapped in between. Therefore, they count as significant, and there are 4. 3.06, there are 3. So notice that the decimal doesn't affect it one way or the other. Not in the case of trapped zeros. 900.0035, all of them count as significant. So if they are trapped in between 2 significant digits, they count as significant. Leading zeros are the ones that come before, if you're reading from left to right, the zeros that come before you hit a non-zero number, those never count. So 0.005, none of those zeros count. There's 1 significant digit. So leading zeros, the ones on the left before you get to any non-zero number, do not count. So just skim right past them till you get to a number that's not zero and start counting from there. So on the next number there are 3. Zeros to the right are the ones that it depends. It depends on whether they measured the place or they're just using that 0 as a placeholder. So if they measured it, it counts, and if it's a placeholder, it does not. In this case, remember that we're talking about measured, not significant, or not important, I mean. So the easiest way for you to look at a number and know is if there's a decimal point, then yes, you count it, and if there's not, then no, you don't. But remember, this is only for trailing zeros. Even a decimal point doesn't work for leading zeros. Okay, so on these examples, 4.00, I see the decimal point, so I count the zeros, so there's 3. 300.000, I see a decimal point, so there's 6. 4,000 decimal point is 4. 4,000 without a decimal point would be 1. So that decimal point makes a difference there. The next number shows you what I was talking about with leading zeros. Leading zeros still do not count. So 0.0 does not count. The 5 and the 6 obviously do count, and because we see the decimal point, the last 0 does count, so 3. In the number 300, I do not see a decimal point, so 1. In the number 0.0050600, the leading zeros do not count. Those first 3 zeros don't count. The 0 in between the 5 and the 6 counts because it's trapped, and the last 2 zeros count because there's a decimal point, so 5. In scientific notation, everything counts. So, everything before the times sign, I should say. You still have to have the times 10 to the something on there if you're writing the number down, but it doesn't count as significant digits. It's basically telling us where the decimal goes. So in the number 3.45 times 10 to the third, 3.45 is all we look at to count the significant digits. In the number 2.000 times 10 to the negative 14, you look at the 2.000, and in the number 4.903 times 10 to the 23rd, you're looking only at the 4.903 to determine significant digits. So in the first one, there are 3. In the second one, there are 4. And then the last one, there are 4. So if we just go through a few practice here, 0.002060, leading zeros do not count, but I do see a decimal point, so the last one counts, and the second to the last one counts because it's trapped, so 4. 98,002, because there's no decimal point. 200.003, everything counts because the first and the last count. If the first digit and the last digit count, everything in the middle is trapped. So 6. Next number, there are no zeros in there, so everything counts. The last one in that column, 0.0000012, leading zeros don't count, so there's only 2. And the significant digit, the scientific notation, 3.500 times 10 to the negative 4. We look at the stuff before the time sign. They are trailing zeros, so I look to see if there's a decimal. There is a decimal, so I count them, so 4. 876,000 decimal point. Those trailing zeros, it depends on if we see the decimal point, so we do. So the person is telling us, I measured out that far, it just happened to fall into the zeros. So 6. 3.2 times 10 to the 46th. Everything before the time sign. 1.000000. They put those final zeros on there for a reason, and they're telling us that with the decimal point, so everything. And the last one, everything before the time sign, so 3. Okay, then when you're going to do a calculation with someone's measurement, your calculation is only as good as the worst measurement. So weakest link. I can give you a number with 2 significant digits and a number with 227. You have to round to 2. It's only as good as your worst one. So if I'm multiplying these 2 numbers together, the first thing you would do is count how many significant digits are in the first number. There's 2. How many significant digits are in the second number? There's 4. The calculator gave me either one of these 2 numbers, depending on whether I put it in scientific notation or not. I had 2 significant digits and 4 significant digits, therefore I must choose 2. So my answer is either 2.0 times 10 to the negative third or 0.0020. Okay, so if we're looking at this example, count the significant digits and what's already there. 4 in the top number because none of them are 0. 3 in the bottom because the 0 is trapped. Remember, we're only looking at the part before the time sign. The calculator answer was this. I had 4 and 3, so I must round to 3. So my answer is 3.1, and then look behind the 5, and it needs to get round it up, so 3.16, and then don't forget to put the times 10 to the 10 back on there. Okay, and these are just some practice. Start by counting the significant digits in each number. So in the first one, I'll go back. In the first example, there were 0.002060. There's 4 because the leading zeros don't count. In the scientific notation number, there's 4 because everything before the time sign counts. So we needed 4. So that's how I came up with the 7.21 or 7.210 because I needed a 4th significant digit there times 10 to the negative 7. So even if it rounds to a smaller number, you still got to fill in however many you need. 98,000 divided by 876,000 decimal point. First thing is 98,000 has 2 significant digits and the other number has 6. So we have to round to 2. So I came up with 0.11 or 1.1 times 10 to the negative 1. Okay, here the first number has 6 and the second number has 2. So I round to either 0.64 or 6.4 times 10 to the negative 1. First number has 7 and the second number has 6. So that's a lot of significant digits. It's also a longer number, so you gotta go to scientific notation on that one. So our answer is 1.76089 times 10 to the negative 4. First number has 2 because leading zeros don't count. Second number has 3 because everything before the time sign counts. So we need to have 2. Now, that 0 in my answer does not count because it's a leading 0. So I can write it like this, or I can write it as 2.4 times 10 to the negative 2. So don't count those leading zeros. A lot of times somebody will give me 0.00 as an answer. You don't have any significant digits in that answer, so be careful with the leading zeros. Okay, this one has 8 for the first and 4 for the second, so we need how many in your answer? 4. That's a pretty big number, so I would require you to go to scientific notation on that. Remember, if it has 5 digits or more in it, it needs to go to scientific notation. Okay, the first number has how many? 2. Second number has 4. So we need 2 in our answer. So we can either go 1, 6, and then fill in with 0 till we get to the decimal, but don't write the decimal. Or we can put 1.6 times 10 to the 2.